Uh, Dear students, I am ending the another topic soaps and detergent of sixth semester. So please note that this is the most simplest and easiest topic already I have quoted. So keeping all these in mind, now let me move again and give some of the important factors connected to this topic. Okay, as the term soaps and detergents you are knowing well, soaps are nothing but the sodium salt of long chain fatty acids, and fats are, detergents are nothing but the long chain alkali of sulfonates of corresponding hydrocarbon or alkyl substituted aromatic hydrocarbons of corresponding sulfonates. Okay, today I want to continue with the same dialogue that soaps and detergents are very useful for day to day life, and without these, nowadays it's very difficult to stay. So, for better health and better care, always you might be heard about the word wash the hand with soaps. And soaps and detergents are cleaning the virus affected, particularly come in contact with your hands and your face. So, keep you healthy from corona just by wearing mask and keeping the distance and washing with your soaps, and the rest part is detergent for cleaning action. Okay, now already I have given the structures and all the factors related to soaps and detergents. So soaps are nothing but RCONA, and detergents are nothing but ROSO2ONE plus and SO minus, SO2 minus. That means already with a simple definition you can remember that long chain fatty acid, R is a long chain fatty acid containing the end COO and which is ending with Na. So that is the sodium or potassium salt of long chain fatty acids are soaps. Similarly, when you want to define the detergents, these are alkyl substituted sulfonates, that is sodium alkyl sulfates or sulfonates. Similarly, the another type is R with benzene ring, SO2 O minus Na, that is a sodium salt of phenate, benzene sulfonates. Okay, so these are the examples. Already you are familiar with the structures. So sodium stearate contains C13H35. Sodium palmitate contains C15H31COO Na. C17H35 is an unsaturated fatty acid present in that is a sodium oleate. And regarding detergents, sodium lauryl sulfate C13HCH2 10 times, CH3CH2 10 times OSO2O minus Na. And another is example of CH3CH2 11 times attached to the benzene ring and SO2O minus Na, sodium para N-dodecyl lauryl sulfonate, benzenate. Okay, so these structures and some examples last time I have quoted, but it is again for your repetition just to remind what you have learned last time. Now today the main thing is manufacture of soap by modern process by saponification. It is also called as a hydrolyzer method. So I have given a simple equation here. Okay, if you look at this particular equation, CH2OCOR, CHOCOR, CH2OCOR, it's a triglyceride ester. When treated with NaOH or KOH, undergoes breakage to form glycerol, CH2OH, CHOH, CH2OH plus RCOONA 3 times, that is soap. R is here a long chain hydrocarbon. It may be palmitic group, it may be oleic acid group, oleate group, etc. So, manufacture of soap involves three important steps. One is hydrolysis of oils and fats in presence of zinc oxide catalyst at high temperature about 300 to 350 degrees centigrade under the pressure of 3 to 400 atmospheric pressure, and distillation of fatty acids under vacuum pressure. This is the second unit involved in it, and the last step involved is neutralization of a concentrated fatty acid with alkali like NaOH and KOH. The procedure is very simple. In a big iron tank, a mixture of oil fat is heated at high temperature and pressure over a layer of zinc oxide porous catalyst and then passed into a vacuum tank under the pressure of about 200 atmospheric to 400 atmospheric pressure. Finally, the liquid fatty acids are moved into the alkali tank and stirred well to get a desired shape of soap, wherein the perfumes and other ingredients are added as per the commercial requirements. So, let us see this simple sketch for this. Okay, now you can see here there are two tanks. One is big iron tank in which the oil or fat which is available easily in market is placed, and in this plant or in this tank there is a porous layer of zinc oxide catalyst is also placed, and from the bottom there is another opening, and from the top there is another opening, and which is further connected to the vacuum tank. So from the top we have to blast the steam. When the steam is blasted in the iron tank, the temperature raises to nearly 300 degrees centigrade, whereby the glycerol molecule, that is a triglyceride ester molecule, will be broken down and glycerol will be collected at the bottom, and which is one of the commercial byproduct of this. And at the same time, the vapor along with your triglyceride move into the vacuum tank. So in the vacuum tank there are several pipes you can see. So here there is a lot of pressure is generated due to the gas generation, as well as there is a pressure pump which will make the vapors of long chain fatty acids are moving towards another tank called as what you call it is a alkaline tank. So in the alkaline tank there is a strong solution of NaOH is placed, and where this vapors of long chain fatty acids are mixed together and agitated, means stirred. So after stirring for several time, the solid cakes are yet to form. So before it get converted into the desired shape, what we have to do is we have to move it into the liquid. Hot solution is moved into the cake pattern modules which are kept at the bottom, and finally one can access with the long chain fatty acids which are converted into sodium or potassium salt of acids, that is nothing but soap. So this is how the soap is manufactured, and this chart you have to remember. So there is a one tank that is called iron tank, second one is vacuum tank, and third one is neutralization tank, and the rest of the process is the conversion into the various processes. Well, so when the neutralization tank consisting of fatty acids along with alkali, there may be some perfumes are added to the soap so that the product will have or smell better, have a good aroma. So that is the purpose of adding some ingredients and perfume at this stage. So finally, the well refined or well fine shape required shape of soaps are isolated and obtained, and commercially they are sold. Well, in the industrial manufacture of soap, tallow, fat from the animals such as cattle and sheep, or vegetable fat is heated with sodium hydroxide. Once the saponification is completed, or sodium chloride is added to precipitate the soap, water layer is drawn off and the top of the mixture, and the glycerol is recovered using the vacuum distillation. Well, in this process, please remember that in the manufacture of soap, we will have a byproduct called glycerol, which is also a commercial important compound of good in nature, can be isolated. So, anybody wanted to start the soap industry, let us look into this modern process, and then we can think of rest of the things. Now, mechanism of soap. So last time I have explained it, but it is again I want to insist because there may be some time 5 marks question. Explain the mechanism of soap. Now at the bottom I have shown here. You can see the okay. Let us see. It is a long chain zigzag path hydrocarbon part. It is a non-polar part, and which is a water insoluble. And at the end, I have shown a little bit of brownish or reddish color. That is a polar part, which is having COO minus and Na plus. And whatever the zigzag part I have shown, that is a CH3, CH2, 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 so on. So that is the hydrocarbon part, which is water insoluble, and carbonyl group is a water soluble component. Okay, so this you have to remember. Now when you place a cloth containing the soap and water and the dust particle present on the cloth, and keep in a big bucket or a beaker, and just wash it with your hand by rubbing, or just to increase the temperature, whereby what happen, the dust particle will come in contact with the non-polar tail, that is hydrocarbon part, and it is having affection towards that oil or fat or oil or dust particle present on the cloth. Then the COO minus, it is a water soluble component which dissolves in water, and the hydrocarbon part will take only your dust particle and removes it. When you shake or soak it, then what happen, the dark unwanted impurity will come out and get separated. So this is the process that already I have explained last time, but as far as my view concern, so you may expect sometime 5 marks question. Explain the mechanism of soap. So you write the general formula I have given, where a long chain hydrocarbon, which is a hydrophilic or hydrophobic, whatever the things are there, you have to write. That is, a long chain hydrocarbon is water insoluble, and sodium salt of a carboxylic group is water soluble component. So these two terms you have to mention perfectly. And the dust particle present on cloth or any washing material will come in contact with your non-polarized tail of hydrocarbon, and it's extracted, and finally when you rub it, it comes out and collected. So this is the mechanism of cleaning action of soap. Okay, now keeping this in mind, now let us move on to the other aspect. As already I have told you, the classification of detergents. So detergents have a general formula R, O, SO2, O minus, and Na. That is a general formula. So these detergents can be classified into 3 or 4 types. One is anionic, second one is cationic, and third one is non-ionic, that is a zwitter ion type detergents. So as the name itself indicates, that anionic means there must be negative, cationic means there must be positive, non-ionic means there is no charge on the detergents. So further, when you see non-ionic detergents, okay, those that develop a negative charge on the water stabilizing material, okay, then cationic, those that develop positive charge on the water, 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 on the water soluble in end. And non-ionic, those that develop no charge, that is non-ionic in nature, on water soluble in ink. And emporic means those that have both positive and negative charge on the molecule. Okay, let us go one by one. Now let us see here with an example. Okay, a typical anionic detergent. A typical anionic detergents are alkyl benzene sulfonate and alkyl benzene protein of these anion is lyophilic and sulfonate is hydrophilic. The two variants have been popularized, and those with branched the alkyl group and the grown with the linear alkyl sulfonates. Okay, let us see one example here. I have quoted aromatic. A long chain hydrocarbon containing CH3, CH2, 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 CH3, that is luryl sulfonate, and at the end there is OSO SOO minus Na plus. So sodium salt of sulfate or sulfonate of long chain luryl sulfate. Similarly, you can see the another example where there is a sodium N-dodecyl benzene sulfonate C6H5O SOO minus Na. So these are the two detergents which are having anionic in nature, anionic with their end. Then cationic detergents. Cationic detergents are similar to those of anionic, wherein the hydrophobic component possesses anionic character. So let us see here this N plus CH3, 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 Cl minus and CH3, CH2, H2 15 times. That is, the central nitrogen molecule will possess the cation, while the hydrocarbon part is anionic in nature, that is CH3, CH2 15. So which is having a capacity to bind with the dust particle or the other type of impurities which are presented on the clothes or even on skin. Okay, so this is methylene hexadodecyl ammonium chloride. So you can see the structure very clearly. CH3, CH2, H15, that is CH2 15 times, and N plus CH3, 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 Cl minus, where this is just like a ammonium chloride, NH4Cl, or the ammonium salt, which is having the positive plus charge with it. And such kind of hydrocarbon components connected to the nitrogen of the ammonia will play a very important role, and it is called a cationic detergent. Now with this we move on the third type, non-ionic. So specifically I will take an example to make you this point clear. You can see here CH3 CH2 14 times COOCH2 attached to the CH2OH CH2OH CH2, a trihydric alcohol molecule with a central carbon attached with a long chain hydrocarbon. Here there is no question of sulfonate group, no question of carbonyl group, anything, but it is having a long chain hydrocarbon, and that long chain hydrocarbon is most useful for removing the dust particle present on the cloth. So that is why here there is neither positive charge nor negative charge present in the molecule. So but what you are expecting, it act as a detergent without any charges. So the specific example that I have mentioned here is pentaerythrin palmitate. Okay, so these are this is an example connected to non-ionic. So I again repeat in simple words: cationic will possess a long chain hydrocarbon with positive charge. Anionic will possess a detergent property with long chain hydrocarbon with negative charge. And non-ionic, that is just like a neutral molecule, though the molecule is neutral but having a long chain hydrocarbon capable of removing the dust particle present on the cloth. So this is how all the three kinds have generally classified, and with a specific example. In some time examination, the examiner may ask the question like, what are detergents? Give the classification with specific example. So simply you concentrate only on detergents. What are detergents? Definition with some example. Then what are cationic, what are anionic, what are non-ionic? That explanation will give you full 5 marks. Now keeping this in mind, I want to move on to the other aspect, that is the general properties of soap. Soaps are made up from fat and alkali by saponification. This is one of the important. Soaps are manufactured or prepared by saponification of fatty acids with an alkali, and these are very cheap compared to the other material. They are not suitable for delicate clothes. So soaps are not suitable for delicate clothes. They are clean better in hot water. Soaps are generally cleaned in a good condition with hot water. They do not produce lather with hard water and are not able to clean the cloth. So that is a drawback of the soaps. Lot of water is needed to remove soap from the cloth. Similarly, when you want to see the properties of the detergents, detergents are made up of a molecule containing sulfonate with alkyl or aryl group, and they are little bit costlier than the soap. They are not suitable, they are more suitable for any kind of cloth, which even the cloth is very delicate. They clean better than soap, even in cold as well as in hot water. They produce lather with hard water as well as soft water. The the soaps are using more water, but detergents are using less water. Okay, keeping all these in mind, let us see there may be some question related to this. Give the difference between soaps and detergents. There may be 5 marks question. So how do you differentiate between soaps and detergents? So better you make the 2 columns. Then whatever you have learned so far regarding the soaps and detergent, you just summarize. So you make the 2 column, one is a soap and the detergent. Okay, here you can write the formula. I have not written, but you can write. What are soap? Soaps are nothing but RCOO minus Na plus, where R is a long chain hydrocarbon. What are detergents? ROSO2O Na, sodium sulfonates of long chain hydrocarbon, or you can write the benzene ring also. So first you write the both structures of soaps and detergent. Then you go for the further activity. I can see in case of soap, they are metal salts of long chain fatty acids, that is sodium or potassium, sodium or potassium salt of long chain fatty acids. What about the detergent? Detergents are sodium salt of long chain hydrocarbons like alkyl sulfonates or alkyl benzene sulfonates. So that is the difference. Second difference is they are prepared from vegetable oil and as well as from the animal fats. So whatever the tallow available, okay, so that is used for manufacturing soaps. Then what about the detergent? These are prepared from hydrocarbons of petroleum or coal product. So whatever the petroleum byproducts are there, which are containing long chain hydrocarbon or coal containing the long chain hydrocarbon, they are used for manufacturing of detergents. But oils and fats which are available from vegetable and animals are used in case of soap. Well, so these are the method of preparation, their general properties regarding the structure, everything is over. Now, when you come to the important factor, that is the solubility. Soaps are used effectively in soft water, but not in hard water, because the hard water produces insoluble precipitate with the calcium plus 2, magnesium plus 2 and Mg plus 2, because there is a RCOONA. RCOONA means the COO containing Na, when treated with a hard water in a washing purpose, the Na is replaced by either calcium or magnesium or iron, and again it will going to form the soap itself, but it will not dissolve. So that is the biggest drawback of the soaps. Now when come to the detergents, these do not produce insoluble precipitate in hard water because there is no such carbonate, there is a carboxylic group. Here is a sulfonate. So almost all sulfonates are soluble in hard as well as soft water. They are effective in soft as well as in hard water or salt water also, if the water contaminated with the salt. So this is how you can distinguish between the soaps and detergents. So soaps have limited application in day-to-day life. The detergents are having a lot of application in day-to-day life, and they serve better than the soaps. Okay. Now, before I end this topic, I will give one example. Already you may be knowing it. That is a glyceryl tripalmitate. That is tripalmitine. CH2OCO, CH2 14 times CH3. Again CHOCO, CH2 12 times CH3. Again linked with another carbon, CH2OCO. That is a triglyceride ester containing the palmitate group. When treated with sodium hydroxide, it undergoes breakage to give glycerol as a very important byproduct and a long chain fatty acid, that is RCOONA. So this is the simplest way you have to remember how the soaps are generated. Now my young friends, so today I have completed the one of the important topic, that is soaps and detergents. So very easy to understand, very easy to represent. There is nothing more to write more and more equation. Only triglyceride ester, NaOH reaction, that gives the product, all these things. So now let me convince you that in this topic there may be certain questions. So what kind of questions do you expect? The first question is, what are soaps and detergents? So this can be explained with their formulas, right? And the second is, explain the cleaning action of soap. It's very simple. Long chain hydrocarbon which is insoluble and carbonate group is soluble, and how it acts already I have explained. Then the third one is manufacture of soap by hydrolyzer method, or it is called as a modern method. So there may be sometime 5 marks question, definite question will be there. So please, without any hesitation, whatever the questions I have given, so on that you try to make a 5 marks answer by going through all the slides I have shown in last 2 episodes. And be happy with your health. Wear mask is compulsory, so you don't think that I'm doing some other extra work. It is my duty to make you too familiar that mask is compulsory for next 10 years, not only 1 year 2 year, it is a 10 years. Okay, so mask, social distance, and washing the hands with the sanitizers, that will prevent you from corona and your family. So with this I conclude my today's discussion. Thank you.